For the most part, surviving damage to the brainstem is practically non-existent because of what the brainstem does. If you go back and think about the pons, the midbrain, the medulla, okay, these are all of the areas that control homeostasis. So damage to any of those areas of the brain usually results in death. Now, there are times when people can actually survive damage very high up, close to this medulla and so forth, but it's very rare, okay? So very seldom does that occur. Do people actually survive that? So damage to these areas of the brain will determine how successful the recovery. I don't know if I would say full. Well, I guess sometimes you can have full recovery, but how successful the recovery will be. One of the things that we think about with the cerebrum, we tend to go, oh, I'm left brain, right brain. And the reason for that, not so sure if one hemisphere, the left or the right, is more dominant than the other. It's basically because each side, either the left or the right, tends to specialize in something. And when you look at whether people go, oh, well, I'm left-brained or right-brained or whatever the case might be, that lateralization, choosing a half, okay, usually it's associated with handedness. What is that? Whether you're left-handed or right-handed. In the case that we're looking at here, the right would be the left control, the left would be the right control, okay? So how many of you in here are like right-handed? Left-handed? Left-handed? Okay. People who are left-handed do tend to be much more artistic, okay? Much more of that ability. Now, it does develop with age. For example, in the early up until roughly about the mid-1900s, okay, people thought that if their child started writing or showing any type of representation of being left-handed, that there was something wrong with it. Because the majority of the population is right-handed. Parents would go so far as to tie the child's hand back and force them to learn to be right-handed. Well, hopefully parents are not doing that anymore, okay? I've always been like, encourage them to use both, because if they're encouraged to use both hands, they're engaging both sides of the brain, which is pretty cool, okay? Which is what you want to do, because the more neurons you can get to fire at an early age, the better that child is. Because they'll be able to have that little bit of artistic ability, be able to have a little bit of the science and math and all that other sort of stuff, and it's actually, it helps create or helps keep those neurons firing for learning, which is really cool. So it does develop with age. Now, does seem like males exhibit more lateralization than females. Meaning, having more of either the right hemisphere or the left. Now, the right hemisphere, which would tend to be associated with left hand, okay, this would be the one where people tend to have more ability for the shapes and the sounds and the music and that sort of thing. So that's why a lot of people who have the left-handedness are really good artistically. Right-handed, well, if it's being controlled by left, well, this is like speech and rationality, math, science, okay? At this point in my life, I totally missed every bit of the stuff on the right. Well, y'all seen my pictures, okay? You've seen that I still use the stick person, okay? I mean, nothing artistic whatsoever. But the math and the science and the reading and the language and everything else, oh yeah, oh yeah. To show you how bad it is for me being left-brained, y'all know all the billboards and stuff like for Chick-fil-A and everything? And even though they're hilarious, I would love to have one of those cabs, okay? Everything's spelled wrong. Everything's spelled wrong. And I'm just like, ugh. My husband's like, let it go, let it go. And I'm like, it's spelled wrong. Everything is spelled wrong. So yeah, so I'm definitely left brain, not the right brain. So our cerebrum, definitely the part of the brain that is the youngest, okay? It's the one that has developed the most over the geological time scale and is the area, and I don't know how I ended up with 2 blank slides, but I did. I ended up with 2 blank slides. Definitely the area that deals with intent, the wanting to have the purpose to do something. The last part of this chapter is dealing with the cranial nerves. When we look at the brain, all the stuff, Roman numerals. All of this is Roman numerals. These are our cranial nerves. We have 12 of them, 12 pair, okay? And for the most part, they're coming from the base of the brain, okay? Now, one of the parts about this, they exit through foramina. Do you guys remember what that term means? Okay, the little holes in our cranium, so our skull case. They're going to lead to muscles and sense organs that are mostly in the head and the neck, being therefore cranial. They're always represented with Roman numerals. So you've got for pair 1, Roman numeral 1, 2, 3, okay? It's just 1, 2, 3, 4, 1 through 12. And then their name. For example, the very first one right here, okay? Roman numeral 1, olfactory, because those are for the sense of smell. And as you continue, like olfactory, optic, all these other ones that are existing, 1 through 12, they're going to be represented by the name. Now, what I would want you to know about this, all right? First of all, be able to label them, all right? So I think either your lab manual or your text has a picture of them. And for the most part, they're directly in order. 1, 2, 3, 4, 5, okay? One of them is switched, okay? And basically the reason for that is they were given their Roman numeral based upon when they were found, okay? So like the first one was found first, second one was found, and so forth. And when they get to the abducens, they were like, okay, well, they didn't realize there was another one, and so there was a flip, okay? That's the only thing, okay? But now, I want you to be able to give it the Roman numeral and the name. Have you ever heard of a mnemonic? Okay. All you got to do is type in, like at a Google search or whatever, a mnemonic for these cranial nerves. You'll get a ton of them. All right. Whichever one helps you remember them the most. Okay. But for the most part, they're directly in order. Now, when we look at what the cranial nerves do, and the reason that because even your textbook will let you know that it's impossible in the scope of our class to learn each one of these nerves, okay? It's a course that is probably taught an entire semester just on these nerves in neurology, okay? So for our purposes, what we're going to do, I want you to learn the names, the Roman numerals, and then we have whether these cranial nerves are either sensory, meaning sensory information gets to move in, or whether motor gets to go out, and then some of them have both. That's all I want you to know, okay? So if we have something that's a motor fiber, what will happen, for the most part, the fiber for that motor function will actually begin in an area of the brain stem, nuclei, which are areas of nerve cell bodies, okay? It'll actually begin in the nuclei of the brain stem and lead to glands and muscles. But now remember, it's all within here for the most part. There's one that runs the entire length of the body, that runs the entire distance of the trunk. Yes, it's really cool, okay? If it's a sensory fiber, usually there's receptors mostly in the head and the neck, and they go to the brain stem, except for the one. Now, I've learned in my time of teaching, okay, that when I get to talk about this nerve, because see, I love this nerve, the one that's going to run the length of the viscera, okay, the trunk of the body, because it's called the vagus nerve. Not like Las Vegas.